All right, my name is Mr. Wyrick. Today for geometry, we're going over this chapter 1 review. So the very first question, name at least 3 real-world examples of the following. A point, a drop of paint would be a point, a good example of it. The end of a pin, like P-I-N, something that you could poke somebody with, that would be one. A line segment, the best thing I can think of is some replacement lead for a mechanical pencil. That would be a good line segment. Your charging cable, if you hold it out straight, would be a line segment. Remember, a line segment just means it stops. It doesn't keep going forever. A plane would be any kind of flat surface, so the top of your desk, the floor. And then an example of a line, they did have a violin string on the paper that we did that accompanied that lesson. Another example of a line, I like to think like the electricity, like the telephone wires, the way those go, that would be another example of a line. I'm sure you can come up with more examples. It's just being able to tell something in real world what it would be. List all the names for the following. This is point K. All right, on number 2, A is just point K. B is segment RW or WR, either way. On letter D, there's a whole bunch of different answers that you could have. This is a plane. A plane is defined by 3 non-collinear points. So any 3 points that don't fall on the same line. So this could be plane ABC, this could be plane BCD, this could be plane CDA or BDA, or any kind of arrangement of 3 out of the 4 letters. You could involve all 4 letters, that would also be the name of a plane, or it has a name down in the bottom left-hand corner of it, and that is a capital X, but that's in cursive. A capital X, all right? Don't just put a capital X. A capital X would be a point. If it's in print, it's a point. If it's in cursive, that can be the name of that plane. Then the last one. This one's a little hard to read, so I apologize if you were working on this yesterday and you didn't really get it. This is line PQ or line QP. That letter out there at the end is actually supposed to be a lowercase cursive L. So line L. Notice that it has the single letter again, but it's not capital, all right? It's not going to be printed like that. It's going to be cursive. You'll also notice, hopefully you noticed, that these match up to the things on number 1. So on number 1, what's a point? Here's a point. On number 1, what's a segment? On number 2, there's that segment. On number 3, what's a plane? And then we've got the plane. On number 4, what's a line? This is what a line is. So that information has been presented to you. You have the answers. You can see exactly what it is that you're supposed to be looking at. Number 3, 3, 4, and 5 for some reason were confusing for some people. What are the other names for line FE? This is line FE. There are 2 other lines on the figure. We give it a name so that we can tell which one we are talking about, and it can have different names. There are 3 points on this line. So line FE could also be line EF. Line FE could also be line FG. It could also be GF. It doesn't have a lowercase letter accompanying it, so that's kind of where we run out on that one. Line DB is this one right here. It could also be line BD. Okay, I can put them in the opposite order. And then it has this lowercase m out there to the side, so it could be line M. Again, we kind of do that cursive. The other names for line CB. So this one's got 3 letters, so it could be BC, it could be BA, it could be AB, it could be CA, it could be AC, and it also has a lowercase l. So a lot of different options there. Just understanding what you're looking at, how you're supposed to look at it, how it could have a different name. Try to skip around just a little bit here. Two sets of collinear points. That just means they're on the same line. D and B are collinear. They exist on the same line. A and B are collinear. They exist on the same line. A and B, or A and D, do not. F doesn't even exist on the same plane as that. Coplanar points with E are all the ones that are over here on plane P. You can see them. You can name any of them. A, B, C, D. Those are all coplanar with E. Where does FG intersect plane P? Understand that this is coming in 3D. It's coming down through the plane. It touches in one spot. That's point E. Down at the bottom, when it's asking for missing length, all you have to do is you add the two pieces together to get the whole thing. So on this one, the whole thing's 21. This one's 10. That means the other's 11. This one is, we don't know, but these are 12 and 5. That would make it 17. Moving on to the next page. Solve for x, same thing. Number 12 was confusing to some people. We had 13 plus x plus 20. Those were the two segments. And they added together to equal 17. We put together our like terms. X plus x makes 2x. 13 plus 20 makes 33. So 2x plus 33 equals 17. I'm going to continue to solve this just like I'm solving for x. I subtract 33 from both sides. I get 2x is equal to a negative 16. I divide by 2, I get x is negative 8. Yes, that can be a right answer there. Okay? The fact that it's negative 8 is fine. 13 minus 8 would be 5. 20 minus 8 would be 12. 5 and 12 make 17, just like it's supposed to. So if you get an answer that's weird and you're like, I don't know about this one, put that answer back in, substitute it into the parts of what it was that you were working and make sure it makes sense. All right? You're going to be taking a mostly multiple choice test tomorrow anyway. So if you come up with an answer that's close to one, look at the answers that are available, pick that one answer that may be close, put it back in and see if it works. You should be able to check your work. You should be able to use the calculator. You should be able to do just fine. I'm going to skip number 13. On number 14, find the length indicated. So you have to solve for x and then substitute it back in. On this one, it's asking me to find FH. This is 12 plus x plus 4 is equal to 3x plus 6. Well, 12 plus 4 is 16, so that's x plus 16 is equal to 3x plus 6. I subtract x, that's 16 is equal to 2x plus 6. I subtract 6, I get 2x is equal to 10. To finish solving this, I divide by 2, and I get x is equal to 5. I'm not done. It wants me to find the whole thing. I can do that a couple of different ways. I'm just going to say 3 times 5 plus 6, that's 15, plus 6, which is 21. If you check the other way, this x being 5 plus 4 is 9, 9 plus 12 is also 21. So I know my answer checks out because the math works. I'm going to skip number 15 just for the video. Number 16 is a little too easy. Number 17 I do want to take a look at. It helps if you draw a line. It says, given that A is between B and C. They're telling you what it looks like. This point out here is B. This point here is C. We don't know exactly where A is. We don't know the distances, but we know it's between them. There we go. BA is 2x. Here's 2x. AC is 6x. This is 6x. The whole thing, BC, is 48. So I'm going to set that up as an equation now. 2x plus 6x, because I know that these are the parts, and they are going to add together to make the whole thing, equals 48. That's 8x equals 48, because those are like terms. I'm going to combine them. They're on the same side. I divide by 8. 48 divided by 8 means x is equal to 6. Use the number line to answer the following. I'm only going to answer a couple of these. What is, on number 19, what is the distance between B and E? B is at -4, E is at 8. I can just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The distance is 12. If it's on a number line, all you have to do is count how far is it from one to the other. What is the midpoint between BE? For the midpoint, I'm going to add them together and then divide it by 2. 8 plus a -4 is the same thing as 8 minus 4, that's 4. I divide it by 2, that's 2. All right? When it's midpoint, add them together, divide by 2. On the next page, the distance formula. We did not spend a lot of time on the distance formula in class, so if I haven't looked with heavy scrutiny at the test, I was mainly just making copies to make sure that everybody was going to have one, and we were going to have different versions so that you wouldn't be taking the exact same test as the person sitting next to you. That way we wouldn't be tempted to cheat, or if we did cheat, it would be super easy for me to grade. F minus, hooray. The distance formula, remember we mainly just talked about a squared plus b squared equals c squared, the Pythagorean theorem. So if you have that, I'm okay with that. The real distance formula is the derivative of this. So you like take the square root of both sides, and instead of having a squared plus b squared, it's the distance between the 2 points. So it's actually written as x2 minus x1. We subtract our x values, and then we square it. That's our a squared. Plus y2 minus y1, the distance between our y values, and then we square it. So that's my a squared plus b squared. And we're going to equal that to d, the distance. Notice how that's not squared anymore. That's because we're going to take the square root of all of that. Okay? That's what the distance formula looks like. If you need to look it up online, take a picture of it, whatever. Again, this review will be posted. You can look at it. The distance formula is not one that's necessarily easy to memorize, but I do believe that the test is mostly multiple choice, so you might be able to pick that one out of a lineup. The midpoint formula, you add them together and divide by 2. x1 plus x2 divided by 2. y1 plus y2 divided by 2. Add together your x's, divide them by 2. Add together your y's, divide them by 2. That's the full midpoint. So over here, what is the distance between A and B? I check my x distance, 1, 2, 3, 4, 5, 6, 7, 8. 8 squared plus, we go up 1, 2, 3, 3 squared. Okay, 8 squared, 8 times 8 is going to give me 64. 3 squared, 3 times 3, that's going to give me 9. That's going to make 73. And I can tell from my distance formula, I'm supposed to take the square root of that. It's not going to come out to a pretty answer. You'll probably need the calculator for this one. But I know 8 squared is 64. I know 9 squared is 81. So my answer should be between 8 and 9. All right? This isn't one that I think can even reduce. So if it just has square root of 73 and what you got was a decimal answer, just check that same square root of 73 on your calculator. Make sure it comes up to the same decimal that you got. This should be 8 point, I don't know what. Okay? The midpoint between A and B is something that's much easier to find. A is 1, 2, 3, 4. It's -4, -1. B is at 1, 2, 3, 4, +4, 1, 2. So negative 4 plus 4 is 0. 0 divided by 2 is 0. Negative 1 plus 2 is 1. And 1 divided by 2 is 0.5. So there's my midpoint, halfway in between them. If you're given a graph on the test, you can even do this and plot the different points that they give you and see if it looks like it's in the middle. All right? Your eye will be a pretty good judge of that. How are angles classified and what is their meanings? You got a right angle, that's 90 degrees. You got an acute angle, that's less than 90 degrees. And you got an obtuse angle, that's greater than 90 degrees. We might get into some later on to where we'll say it's greater than 90 but less than 180, but we're not there yet, okay? Number 26, name this angle in every possible way. This can be angle R, it can be angle 2, it can be angle QRS, it can be angle SRQ. That's what it means by name it, okay? We're not necessarily labeling it as acute or obtuse in this case. It looks like it should be obtuse, but that's not really what they're looking for. Number 27, find the missing angles. This is one of the most important ones on here, okay? The measure of EBF. We know this is 90, we know this is 50. That's going to make EBF 40. The measure of angle CBE. We know that this is perpendicular, so we should know that this is also perpendicular. That's 90. The measure of angle CBA. It's like, hold on, what's CBA? It's down here. That doesn't make any sense. There's no measurements, but it's a vertical angle right here. It is also 50. And then the measure of angle ABD. Notice how we have a complete line here. That would be 180 degrees, and this one's already 50. So 180 minus 50 means this one's 130. Okay, almost done. Taking a look at the back. We have an angle bisector, so the whole thing is 82. And half of it is 5x plus 11. So all I did on this one was 82 I can split in half easily. So 82 divided by 2 is 41. So 5x plus 11 is equal to 41. The important part of this is the setup. Once you have that, you should be able to get x. You should be able to find the measure of any angle from there. I'll come back and fill that in just for the video's sake. I'm going to move on. If the measure of AED, that's this one right here, is 16y plus 10, find the value of y so that these two lines are perpendicular. That's going to make this a right angle. That's going to make that 90 degrees. So it's just 16y plus 10 is equal to 90. I set that up. I solved that out. I should be able to figure out y from there. Then this last one, again, it's a combination of a bunch of different things. Find the value of x. This looks like it's going to be difficult, but these are vertical angles. That's 9x minus 5 is equal to 58. Find the value of y. I can see that this is a right angle, so that's 7y plus 27 is equal to 90. Find the value of angle 1. It's going to be a little weird, but I should be able to find angle 2 based on what my angle right here is. Okay, this is 58. This is going to be the rest of the way to 90. All right, so 90 minus 58 to find the value of that angle 2, that should be 32. So then the value of angle 1, I'm just going to take 180 and subtract 58, or this would be what, 90 plus 58? I could do 90 plus 58 and get that same thing, because that's going to be vertical angles across the top. Or not 90 plus 58, 90 plus 32. And that should give me the same answer because of the vertical angles. Couple of different ways that you can put those all together. If you get confused on how or why they fit together, make sure to ask during class. Stop by, ask real quick before the test, or show up at tutorials.